In the previous video, we learned that the USB Type-C source communicates the current limit by controlling the pull-up resistance or implementing a current source. Table 427 from the USB Type-C cable and connector specification provides the possible implementations. We also learned that the USB Type-C sink can decode the advertisement by measuring the voltage across the pull-down resistors and using a mapping table for the three current levels: default, 1.5 amps, and 3.0 amps. In today's video, we will learn how to decode the advertisement using a window comparator. Functionally, a window comparator produces a digital output signal based on whether an input signal is in or out of a window. That is, the window comparator tests if the input signal is simultaneously above a minimum threshold and below a maximum threshold. This is useful because the output signal can then be used to control downstream components or communicate the current state of the system. As the name suggests, a window comparator uses two independent comparators to simultaneously compare the input signal to the minimum and maximum thresholds. Let's see this in action. Here's a piece-by simulation of the Texas Instruments TLV7041 comparator. Suppose I have an input signal, sig in, and I want the output signal, sig out, to be high if sig in is above 1 volt. I can do this test by connecting sig in to the N+ pin of the TLV7041 and setting the voltage on the N- pin to 1 volt. As you can see, sig out is pulled up to 5 volts. If sig in drops below 1 volt, for example 900 millivolts, then sig out is pulled low. Thus, the comparator output is high if the voltage on the N+ pin is greater than the voltage on the N- pin. This suggests that if we want the output signal to be high when sig in is less than 1 volt, we must connect sig in to the N- pin and set the voltage on the N+ pin to 1 volt. As you can see, sig out is now pulled up to 5 volts. With some small tweaks, we can use this idea to implement a window comparator to test if sig in is greater than 1 volt and less than 2.5 volts. In today's video, we introduced the basic functionality of a window comparator and offered it as a solution to decode the current advertisement. In the next video, we will implement the complete detection circuit and test it using PSpice. Thanks for watching, and remember, it's not optimized yet.